I don't really remember. There it is. And the other thing that I wanted to do, again, just miscellaneous cleanup, is one thing that I did notice is we don't pass any mouse input to the game. And we don't need that for any particular reason because we won't really be supporting the mouse as a controller. Like you'll be playing with the keyboard because it's kind of more of a digitally kind of game. So the mouse isn't really probably going to be appropriate. But what I would like to do in case we want to develop some debug overlay systems that might be more appropriate for using with the mouse, or if we want to use the mouse to like move elements in some kind of an editing mode or anything like that, what I would like to do is essentially introduce here just some mouse debug stuff, right? So, you know, something like, you know, a mouse buttons flag and a mouse X, mouse Y sort of a situation. Just something like that where we can sort of pass the mouse information to the game. And it can be super janky and awful. It doesn't even matter because it's only going to be used for our debugging purposes. But, you know, I just kind of would like to have something like that in there. And maybe we'll use the half transition count thing. I don't know if that's a good idea. Maybe we'll use the half transition count thing for that since everything else uses it. So maybe we'll do something like this where we do mouse buttons and we say, okay, you know, how many mouse buttons are there on this thing? I think there's 5 on this thing. I don't know if mouse button have so many, mice have so many buttons these days. And then of course we've got a mouse Z, I suppose, as well, which is that little mouse wheel thing. And so I just want to create that state there, have it so that the game can get it. And also let's go ahead and just drop in, you know, something where we can see if we're actually passing that correctly, and then I'll pass it correctly in Win32. So we have that we have the render player thing, right? We have a render player call. Let's get that up above my head. And so maybe we'll just go ahead and say, let's render where we're getting told the mouse is, right? So we have a mouse X in the input layer, and we have a mouse Y in the input layer. So let's just go ahead and do that so that we can see that we have that mouse cursor position. And then I will go in, that should compile now, I think. Yeah. I will go in and just add the minimum necessary nonsense to get the mouse out. So basically in here, if we only care about where the mouse is right before we call it, really, okay, so when we process our like X input stuff, we do our controller input stuff, we can do it right here. We have that new input pointer, right? We have new input, and we just want to go ahead and set these values, all these values here. So that'd be mouse X, new input mouse Y, new input mouse Z. I don't know if we can get in the way that I'm about to do the other ones, but if we don't support mouse wheel right now, I don't really care. That doesn't actually matter to me very much. And then we'll at least track those 3 buttons as well there, or buttons as I occasionally say them. Nice spelling there, Casey. So what we can do if we just want to if all we need is just some mouse information, there's actually a get cursor pause function in Windows that will basically tell you where the mouse is at any given time. It's pretty trivial to use, right? Basically what you do is you call this, and the main cursor, whatever the main mouse is on the system, wherever this little thing is that I'm wiggling around right now, when you call that, you can just get wherever it thinks that thing is. So basically, we can say this is the mouse location. We can get that. And then we don't even care if this thing fails or not. It literally does not matter to us because this is strictly debug information. So we can then take a look at this point structure that comes back, and it gives us this long x and y. Now the problem is if we use this directly, well, you know what? Let me show you what happens if we use it directly, so that you'll understand exactly what I mean. So I won't have to give this explanation blind. You can actually see what actually happens. So if I go ahead and run this, you'll note that we are getting that mouse. You can see that we're getting that mouse position, but you'll notice that it's wrong, right? You see how that's kind of wrong? So what's going on there, right? Well, what's going on is when we call that get cursor position function, it gives us back the cursor position on the screen. But our window, our coordinate system actually that we're drawing on, I know we haven't covered coordinate systems much yet. We're going to talk about that a lot when we get to the renderer. But if you think about it, if we say the point 0, 0, we're talking about this point right here. But on the screen, 0, 0 is up there. So you can see it lines up exactly where if I move the mouse all the way to the top like that, now we're in the upper corner. So what we need to do is we need to find a way to sort of map that cursor position into our Windows coordinate system, because this is in the wrong coordinate system. And coordinate systems, like I said, we'll talk about a lot. So if you don't know what those are and you're a little lost right now, it's totally okay. Just ignore it. We are going to talk about this a lot later on when we start implementing our coordinate system stuff. So you will have plenty of chance to kind of understand that. And this is not an important part of the code that we're writing right now. So you can literally ignore this entirely if you want to. I believe there is something called screen to client, if I remember the name correctly. Screen to client will basically do that mapping, the exact mapping that we want. You pass it a window and you give it the point, and it just maps it from the screen into your client rect space. Now you remember we did that get client rect thing that basically says what our window rectangle is. Well, it's literally that mapping. It maps it into that rectangle, which is exactly what we want, right? So we can just say, hey, get the screen to client for this window that we've got and map it for us, please, right? Oops, missing a slash there all of a sudden. So that will correct it, and now you notice that it is right on target. Now remember, we're drawing our rectangle as if the upper left corner is the position, so that's why it's there. You know, if we were actually doing a mouse cursor, we might want to do an arrow, or we might want to like center the rectangle over it or something like that. But for now, we can tell that we're getting the input properly. So really all we need to know now is we need to know whether or not we had a mouse button up or down. So the way we could do that, if we wanted to, is we can sort of do that in line with that, with when we sort of do all that keyboard processing, you know, this sort of stuff. So what we could do there is we could say, all right, let's go ahead and process mouse up, mouse down messages here, right? We could, I think we also could get them. We might be able to just kind of. I'm so torn. I'm so torn. It depends on how robust we actually want our mouse processing to be. Since it's just debug, I'm tempted to not even bother. And maybe just see if we're fine. Basically, I'm tempted, here, ladies and gentlemen, what I am tempted to do I will tell you. I am tempted to just go ahead and just query it straight away, right in here, and just see. Oh, it's. All right, I think I'm going to do that. So I believe this is crazy. You know, don't ask me why I know all this stuff. It's just a, you know, you wish that your brain didn't even have this information in it because it's just so ridiculous that I even know this stuff. So basically, there's a function that gets the state of the keyboard for you. And it's the state of the keyboard as of your last message that you pulled off of the message queue, because Windows tracks that for you. And so you may be asking, why would that matter at all? Why would we want to do a get key state call? And you can see that it returns the high order bit is set if the key is down, that the high order bit is not set, then it's not down. And it's a short, so it's 16 bits. So basically, we could use this to see whether keys are up or down. And you may be saying, why would you care about that, Casey? Because we are not looking at the keyboard, we are looking at the mouse. Well, if I remember correctly, and sadly, I think I do remember correctly, you can actually ask for the mouse cursor VK code. So basically, if we do something like look at the VK code table, which I assume I can just look at here, virtual key codes, and just typing any VK in there. Oh, there it is, right? This is exactly what I'm talking about. You see those? VKL button, VKM button. You can ask for those as if you were asking for a key. So I can literally go through here and ask for the R button, the M button, and these X buttons, which are those extended buttons, X button 1, X button 2. I can ask for those as if I'm asking for keys. I can ask for them at any time, and it will tell me whether or not they're down. So, you know, let's just do that. Let's just go ahead and do that. I don't actually remember, we think we have a utility call here that'll do this sort of weird stuff for us that we needed to do for our cycle counts. So where was that guy? It was went through to process keyboard message. This is actually, I think, all we really need, right? Because we're sort of treating this right just like a keyboard message. everything that I've written down as to-dos, and just make sure everything's cleaned up, because I want to start the math stuff clean, because I think the next thing we need to do is start talking about math pretty seriously. So I want to go through and just clean up anything that we haven't sort of spent enough time just to kind of get out of our way. And then we can kind of bring our first week of programming to a close. All right. So let's take a look here. We already did yesterday. I snuck in one of the main things that was on the to-do list, which was to fix, to put in a lock file for our PDB so that our hot loading would load debug symbols all the time. It wouldn't, so that Visual Studio wouldn't get confused. So that was a good thing. We took care also, another thing that I had written down was that I wanted to make sure that the people who were doing work on other platform layers wouldn't have trouble. So we cleaned some of that up and moved stuff into Handmade Platform that would help them. So that's finished up now as well. Let's see. I think the only other stuff I have here is, first of all, I don't know if we ever fixed this, but I believe someone was saying that we still had a version of T-Sign sitting around. Yes, we do. So we still had T-Sign sitting in the Win32 sound output, even though we weren't using it anymore. So I wanted to get that out of there so people aren't wondering what that variable's doing there. So I can just call this, and it'll do exactly what we want, right? We can just, oops, that's great. We can just do this, I think, and then use that this get key state for whatever the button is, and it with that top value. And I believe they said that it was a short, right? So the high bit is going to be 1 shifted up by 15, if I understand the documentation correctly. So that's like all we really need to do, I think. Let's find out. Let's find out. L button, M button, R button, X button 1, and X button 2 will be in there. That'll be lovely, I suppose. And I think in theory, that is it. Let me see if that's true. New input mouse buttons is not a member of new input. Is that true? Are you lying to me? I doubt you are. You're a compiler. You don't often lie, although sometimes you do. You never know. So game input, mouse, oh, well, if you spell it wrong, there you go. All right, so I think that's literally all we need to do to process that. Yeah, I don't think there's really much else we'd have to do. And we've got a to-do here if we ever want to support mouse wheel, which, I don't know. We don't really have zooming in this game because it's a 2D game, so we probably don't really need the mouse wheel for anything, but if we found out we did, we would be sad because we're not supporting it. All right, so what we need now is just some way to see if those are working. Let's go ahead and, again, leverage our render player function here. When you can render, you'll see this. This is just how programming works, too. It's kind of cool. Soon we'll start to be having a lot of functions that we can reuse. We haven't really gotten to that point yet, but we're going to be there very shortly once we start building renderer tools and all these other tools. And it's kind of nice. Once you have one thing working, it builds on itself so quickly. Like before we had really no way to indicate anything, and now we can just call this one function that draws a rectangle. Excuse me. And we can essentially use that function to do all sorts of other stuff. So, right, for example, I can do something where I just say, all right, mouse buttons, 0 ended down, right? I think that's what we have as our thing. I can just do that and see, I should see a rectangle happen. Ooh, what did I do? New state ended down is not equal to is down. Okay, so that's our assertion there. I guess I don't actually know if this will work then. Do we? Because we don't. Okay. We don't send this guy toggles. So this would still, yeah, this So I wonder if I just want to make this function. You see what happened there? What happened was we were previously guaranteeing essentially that we always handed this guy is down, not is down, not is down. We would never hand it like 2 is downs or 2 is ups in a row because we were processing incoming messages. I think what I'd rather do here, because I want to make this more robust so I can just throw it whatever this current state is and have it work. I think what I want to do is kind of just say, you know, if it's not equal, then do the processing. And that will just work at that point, right? Because that way I can use it for more things, and I don't know, I feel like that's just going to be more what we're going to want. So I can throw stuff at it and it just works. So you see that up in the corner, do you see that guy there? That's showing us that the button is down and pushing the button up, down, up, down, up, down. So that's totally good. Let's go ahead and real quickly drop a 4. I'm going to drop a 4 on this, yo. Let's go ahead and whip out that for loop. Everyone knows how much we love a for loop. Button index, right? Because I wrote this once, no need to write it again. Just write it once and throw a loop in there, right? Let's go ahead and loop over all of the ones, right, that are in this array, this mouse buttons array. I can just say for everything in that array, however many there are, I'm going to do one for each of it. And then why not go ahead and add something, let's say 20 times the button index, to just move it over. So I'm basically going to move where I render over by 20 pixels every time we increment that button count, right? Off we go. There's our first 3 buttons, left, middle, right. There's our 2 X buttons on the side. There we go. Mouse input done. Completely finished. So that's always good. Can I hold them all down at once? Yeah, there we go. It's hard to do on my mouse. I don't have like, you know why? I don't have some kind of crazy gaming mouse. I need one of those mice where you put like weights in them so your mouse is like totally perfectly counterbalanced. That's the way you get the high scores, yo. Like, who uses a mouse without weights in it? It's ridiculous. Come on. I'm totally behind the times. All right, so that's all we really needed for math. What was the reason for choosing get cursor pause instead of just responding to the WM mouse move message? Is the message pump not fast enough? No, it was just convenience. Since we were only going to pass it once per frame anyway, I figured why bother handling a message? Why not just ask where it is when we're about to pass it? Just easier than doing the other thing. In your mind, what would be a good way to demonstrate to a potential employer proficiency in the type of engine programming you are teaching? I know this is a long way off and I'm still just learning, but to prepare for the future, what would you recommend? To be honest, I have no idea. I I am not involved in the kind of hiring that happens at like lower levels of game development where you're talking about like an entry level position or something, like an entry level engine programming position. So I don't know how those decisions get made, and I don't know how people come to the attention of the hiring people. So I'm afraid I can't really answer that question. All I can really tell you is that at the end of Handmade Hero, if you actually understand everything we did in Handmade Hero, if you really do understand it and could do it yourself afterwards, then you would be immediately able to contribute to an engine team, I think. But how that translates into getting hired, I don't know, right? All I can guarantee you is that I'm teaching you the stuff that the mental processes, the code structure, the architecture understanding, the way to debug things, the way to profile things, that's good enough to be on an engine team. That we can guarantee. Now, how to get hired on an engine team, I don't know. So that's like something for an HR person, perhaps, to answer. But I'm not too familiar with that. Chasing. Have you ever dealt with programmer burnout, or how do you deal with the fact that often there are days almost no code gets written, and on some days massive amounts of code gets written? So I guess what I would say is I rarely have any problem with programmer burnout if I'm just writing code that's supposed to do something. So I've never had that happen per se. What I do have a problem with is when I'm trying to develop a new technique and I just don't know how to do it, right? Like when I'm working on something that either I don't know if it's even possible, which can happen sometimes, like you're like, I don't know if what I'm trying to do is possible. Or if I'm working on something where I'm like, I'm not sure how this architecture should work, and there's a lot of different ways it could work, and I have to kind of think them through. Those sorts of things, you can definitely get into that situation where like nothing is getting done. Typically what I try to do in those circumstances is be self-aware enough to recognize the fact that nothing's getting done. So recognize the fact that you didn't do any work today. Be like, okay, we're in a bad situation. And then what I would do is I'd take that opportunity to go, all right, I'm going to write at least an hour's worth of code tomorrow on whatever first comes to mind, right? So let's say I'm having a lot of trouble with this architecture and I just can't figure out the right way to do it. Then what I tried to, and like no code got done today, like nothing got done. It was like 8 hours of sitting in front of a computer and doing nothing. Then the next day what I'll try to do is just like, all right, I'm going to take the first thing I think of for this architecture, even if it's absolutely the stupidest idea. Like whatever my last thought was, that was what I got to when I was trying to figure this out. No matter how dumb it was, I'm going to just implement it. Because a lot of times what you find is just getting the code out there and then having something to work with is enough to kind of break through that barrier. And so typically what I find is the way that you get into those stuck situations, the kind that you're talking about, those stuck situations often are because you're not coding. You're trying to think something through and you're trying to think it through too far. And you've reached the limits of what your mind can comprehend without seeing it and without playing with it. So what you need to do is get it out there. And so I usually find that that's the way to do it. And if you can just make sure, just force yourself to write an hour of code a day in those situations, eventually you'll break through and you can get back up to writing a reasonable amount of code. The only thing you must not let happen is stopping writing code entirely. When you do that, you run the risk of getting into that circumstance where you have several days and you don't get anything done. So that's what I would say about that. Any source or book recommendation for understanding the concepts you use better? Not really, because I don't think there's been a lot of books that are... Like, I find that most programming educational materials, when I look at them, I'm kind of horrified at the things they're teaching. I'm like, that is not the way to be an effective programmer, right? And so I have a hard time recommending anything because I'm like, I don't know. I'm not sure. There might be some books out there that are good, but I don't know what they are. Certainly the books I read when I was learning to program are not good. Yeah. So I don't know. I'm sorry. I don't have a really good recommendation. Have you seen Game Programming Patterns by Robert Nystrom? I don't think so. Although I think someone has sent me that recently. I haven't read it yet, but I think someone was talking about it. Are you going to use any design patterns? So the phrase design patterns is a little confusing to me because people use it differently to mean different things. I guess what I would say is I have my own set of ways that I do architecture, and you could call those design patterns. They're like whatever you want to call Casey's design patterns, and they're like, these are the ways I tend to structure things. And in that sense, then yes, I would. Like you would see these sorts of things used in various places of my code, and they're similar, right? In terms of design patterns, like the design patterns that are maybe in the book Design Patterns, I find that those are very odd things to call design patterns because they're more like utility classes or something. They're really strange. Like, I don't really understand what people mean when they say design patterns because I feel like different people use it to mean different things. So it's hard for me to answer that question, if that makes sense. Do you find it useful to learn many different languages to gain perspective? No, I don't. I think programming works from first principles very well. So I think what's valuable to learn is how CPUs and hardware work. That's what I think. Because anything you will ever do with a language is just generating stuff for the CPU to do. And so the most important thing is that you understand how the CPU and the system works. If you understand that, then everything that is efficient about programming can be built on top of that. And in fact, when you think it through from first principles in that sense, that is the easiest way to recognize and realize what's so bad about modern high-level languages. Because you can see as you go up each level, you go, okay, here's how the CPU works, here's how I'd program in assembly language. Here's how I program it in C. Okay, that's okay, but I lost some stuff. And you can sort of see what the problems are in C just by looking at what you can do in assembly versus what you can do in C. C loses a bunch of things, and you're like, that's a bummer. So a better C language would fix that. And then going from C to something else, like a Python, a Ruby, or C++, or whatever your higher level language of choice is, you can see how they basically just don't get it. Like the people who design those languages don't understand what you actually needed to make your job of programming in C easier. Because, or rather programming in assembly language, you might even say easier. Because they don't allow you to loft the commonalities up, which is what you're trying to do. You're trying to make something that will allow you to say, here's the assembly language that I wanted to generate. I want to specify that once, and now I want to loft that up into something that I can easily specify in a variety of ways such that it meshes properly and does, things properly and whatever. It's so obvious when you look at it what you really should be doing to get to that high level language. And I don't know why universally almost all high level languages don't even seem to try to do the right thing. I don't know. I think it may be because the types of people who do language design maybe aren't the types of people who write efficient programs. It might be because languages are hard to write, and so you spend a lot of time focusing on other things and don't realize that you should be focusing on this. I don't know. But I find that whole high-level language mess to be rather frustrating because I find like they're mostly not very intelligently done. That's what I would say. What do you think about using VCS for one-man projects? I always do use version control for projects, even my own projects. I have one that I wrote myself, and that's what I use. I wrote it to do the things that I want to do conveniently. And so I would recommend using a source code control system. I don't super like the ones that exist currently, which is why I wrote my own. But I feel like most people can usually find one, existing one, that's suitable enough for them and use it. So if you can find one that's okay for you and that you're comfortable with, then you should use it, I think. What's your mindset when looking at a problem that's new? How do you approach a new coding problem that you have no predefined idea on how to solve? So we will be seeing that in the stream. So like I've intentionally set up a bunch of stuff like in the game design that I've never done before in a game logic or anything, and so I will be sort of showing you how I work through it. I'll make all the mistakes. I'll rectify them. I'll revise the architecture. I'll do all those things so you can watch me do them. So that will be very well elucidated as we go through the stream. Will I write a book after Handmade Hero is done? No, I don't think so. I think Handmade Hero will be probably... How does your source code control differ from something like Git or SVN? Well, basically it's designed just to be used by me, so it's basically it's one command. You type cmirror. That's it. So whenever you're done working for the day, you just type cmirror in, and that's it. There's no push, pull, update, get, grab, frob, diff, whatever. It's nothing. It's just like cmirror. That's it. And then you just have a directory on the server that's got all the versions. So if you ever want anything, you can just go browse them and grab the one you want. So it's just designed to be as simple as possible and stop getting in your way. I find that like Git and SVN make me do a bunch of stuff that I don't want to do. Like I don't ever want to think about the source code control. As far as I'm concerned, the source code control is just a safety net. It should only be there to catch when I've accidentally like deleted a file or accidentally modified a file that I didn't want to. It's only supposed to be able to get that back for me. And anything else it does slows me down and I don't want it. So yeah, it's one command, that's all, cmirror. And I vastly prefer that. Okay, looks like we've come to the end of the questions. It is 1:30. I wanted to go ahead also, and in our platform code, if you remember, we talked about this a little bit, but people were talking about it on the forums. Sometimes people talk about stuff about the code in the forums without having actually watched the episode where I explain why things are done, and they were upset about this because they didn't like the fact that I was using pound defiance. I think they were maybe macrophobic or something, which is not a very good way to be. You don't really want to be macrophobic in C or C++ because C and C++ have extremely weak text processing ability built into them. Macros are pretty much your only option. I wish they had a lot more power in the macros or a lot more power in the language, one or the other, but unfortunately they have neither of those, and so that's where you're at. Anyway, the reason for these guys, again, I'll just restate it, is that static as a keyword in C actually means many things, and I do not like that fact. Not because of readability. This has nothing to do with me being able to read the code, because I would always know. That was what the person was saying on the forums. They were like, I think a C programmer always knows what they are. Sure. But that has nothing to do with it. Readability has nothing to do with it whatsoever. It's searchability. You want to be able to know where your global variables and your local globals are at a moment's notice. And if all of your functions have static in front of them, then you can no longer do like automated grepping to see whether you have any global variables, for example, in your code that's supposed to be thread safe, or in DLLs that you don't want to have any variables in them, like we're doing hot loading, so we better not have any globals in them. If you want to do a grep, like I want to be able to say, at any time, I want to be able to say, show me all of the global variables. And I need to know that I can guaranteedly get that back, right? And so, for example, this right here is a global variable. Now I know what's the one global variable that we have inside our program. It's this guy, right? And that's okay because he never changes. So that's a really quick way for me to immediately know that our DLL is okay. Similarly, I can say do any of what do I call it? Our functions have any of those in there? What is it? Local persist. Local persist. There we go. And thankfully, we don't have any of those. So we don't have to worry about them. That's the reason you do this, and you absolutely should. This is not, I don't think, a matter of taste. You really want to be able to do that searching to make sure that you don't have serious problems you just aren't going to notice until you have some really crazy case of a multi-threaded problem that you didn't realize could happen because you had global variables and something that was getting called from multiple threads. So basically there's that, but what I wanted to do is I also wanted to define static to no, like OMG, do not compile bad, right? Or something like that. To make sure that we can put that somewhere where it's not going to actually ever happen, right? Trying to think if there's some way we can do this. Because what I want to do is make it so that like, so these, but this macro is going to get, I'm trying to think of what I could do. I want to basically make it... I was trying to think of what I could do. I've never done this before. I was trying to think of what I could do so that static could never be typed by itself. But it's going to do the replacement twice in a row. You know, like if I pound define internal, then it's going to replace it with static, and then it's going to apply the other macro. What I want to do is not have it apply the other macro. I'm trying to think if there's any way I could actually make that happen. I wonder if this works. Probably not. It probably only works with, well, actually, let's see. Let's see if I can do this. I'm just, macros are kind of nasty in C. All right. Let's see. Let's see if we can outsmart the macro system, you know, being our, oops, it's no good, being our wily little selves. Okay. So I tried to outsmart it by saying, well, maybe if I can paste combine static into a new thing, maybe that will work. But I guess not. Oh, well, new line and constant. So that's actually just because of that. So that's fine. Let's take a look. So no, we can't. I was thinking maybe if I paste combined them together, you know, so that basically it would be the result of a paste operator. This pound is the paste operator in C++'s macro processor, which basically takes two inputs and welds them together. And I was thinking, I wonder if maybe it wouldn't do replacement on those, but apparently it still runs the macro processor even on those. So there's no refuge there for us. I don't know. Yeah, I don't know. It's unfortunate. It is unfortunate. But it doesn't really seem like there's something I can do. Oh well. So that's I guess just something that will have to be left for our own sort of our own diligence. So basically, what I'll have to do, which is what I normally do, is just this. So I'll have to do a check, which basically says, okay, what, you know, where did I actually type static, and let's make sure that it's only in those particular places. So what I could do as well is basically, you know, we have our build.bat. We could also have a thing which is like static check.bat, which does something like statics found, and then it does that that sort of feinster minus. It does this line of code basically. Oops. So it does that, and searches for all of the things that we might want to find. So basically, something like this. So we'll search for local persist, and we'll search for global variable, and we'll do basically this. So statics found should be nothing basically except for the header file, and then globals found. We'll do that, and I'll be able to go ahead and run this. This is basically the poor man's version of what I just did, and that can basically tell me very quickly. Oh, and I should also do instead of doing these as there we go. Do an echo off like so, and these will have to basically be something like that. I don't know if you can you do like a space? No, you can't really echo a space, it looks like. It just it just actually echoes. That's funny. All right. Well, we'll use that for now. So this way we can actually, I guess, go ahead and get an easy report. We have a good to check from within email, something like, which is like, I'd like to check for, right? I don't really want to check inside it that way. And then that'll be good enough. So that way I can always go out here and check periodically if I want to sort of say, all right, here's all the stuff where we actually type static. And so we'll make sure that essentially it's never anything other than these 3 lines, right? If we see anything else there, we know we've made a mistake. Those globals layer, which is what anything in the game code, you know, that it is something which has to be a constant, right? It had better be something that's never going to be mutated, and in this case, that's true, and so we're fine with that. And again, the reason for that is we're doing hot loading, so even if there was a, you know, even if there was a totally legitimate reason to use a global variable, we need to use another method so that our hot loading would work for any global variable that's going to be mutated, because, you know, if we're changing that global variable, and it was baked into the data segment of the program, which is where these global variables are going to be. When it gets reloaded, we won't have those changes that were made, right? The reload of the DLL will clobber the changes, and that will break our hot loading. So we don't want to ever do that. All right. I think that's about it for that. I think that I had written down here, which is about the static stuff. So get rid of that. We couldn't quite do what I had hoped maybe might be possible, but sadly was not. Just if someone can't type it, we're worried about the mouse cursor. And we kind of talked about this a little bit, but there's really no reason for us not to just fix it for now. We haven't really, you can see that we've got it to do here, which is control cursor visibility. And so actually, you know, we have a fair bit of time today. I want to kind of look at these. I feel like just looking at these here. I feel like, so first of all, time begin period, I feel like we did, right? We did do time begin period, yeah. So basically time begin period and sleep got done. We haven't really finished our timing loops because that's going to be for later, but we did do that. So a couple things that we had here. One was also, we had that, the stuff that I was working on there where we had the, sort of we had done a little work where we could actually show the game while we were in the editor. And I'm kind of thinking maybe that's something that I'd like to bring back, because we've had a bunch of times where it would have been nice to have the game still showing in the background behind the editor. So I don't know, that might be something to talk about. And then also toggling full screen support might be a nice thing to do. It might be nice to start thinking about changing the resolution of things and allowing that to get passed down to the game, because I think that's something we want to use for renderer tests and stuff. I don't know, it's something to think about. But it looks like the rest of these are stuff for later on down the road. Let's see. Getting a handle to our own executable file, I think we already essentially did that as well. Well, we didn't quite, so I guess those will be there. All right. So I think we'll leave those for now, but I'm going to go ahead and first tackle that set cursor because we don't do that currently. And you can see that that has one particularly odd effect, which is basically that whatever the cursor, people were wondering why it's the spinning weight thing. And the answer is it's not actually the spinning weight thing. It's whatever the cursor was before it entered our window. Because we don't respond to the WM set cursor call, and we did not set a cursor in our wind class. What Windows does is it just does not touch the cursor state when you move it into our window. So what that means is you can change it to anything you want just by like getting it to that thing and quickly hopping it over, right? I couldn't quite get it without passing over this, so it turned into that. But you know, if I could get it in there, yeah, you can see if I can get it in there without it going over the line, you can make it be the arrow. And if I moved it in this way, it would always be the arrow because we're passing over that thick band. Same this way, right? You can see I can make it be the text edit cursor if I really wanted to, probably. Can't quite make it. But you get the idea. So basically, that's what's actually happening at the moment. But if you look at what's actually happening, and in fact, we could talk about this because we never really talked about this. It's not super important for us because we just don't have a lot of it going on. But There is a tool in Visual Studio called Spy++ inside the Tools menu. If you open it, you get this sort of thing that's like a list of windows, right? And our window is one of those windows. You could find it in this list. These are all the windows that are in the top level in the system. You can see Krita has a bunch of pop-ups that it creates and other sorts of things like this. And you can see Visual Studio in there and blah, blah, blah. And here's our command prompt, that sort of thing. There's Emacs, right? Good old Emacs. What this tool allows you to do, it's much more handy for applications. It's not something you typically use for games a whole lot because you just don't process that many window messages at the end of the day. But just for educational purposes, this particular tool does allow you to do a few things where you can kind of see what's going on in your application as far as Windows is concerned. What you can do is you can go to Find Window, so you don't have to look in this list, and it gives you this hilarious little crosshairs that you drag and move over a window, right? And you can see that it's found our window, Handmade Hero, and there's our Win class, just like we registered it. And if I hit OK, that basically will bring me right to where it is in the list. And so, you could also just look through the list and found it, but, it's a little quicker to do it that way sometimes. Once you have it, you can go ahead and you can right-click and do Highlight if you don't know where the window is, and in theory it's supposed to blink, but I didn't actually see that happen. I don't know if that's an interaction with OBS or something. It's supposed to kind of blink the window for you, but really the thing we care about is, well, you can look at properties as well, which is kind of fun. You can look at what window styles are set in your window, and you can see other kind of stuff like this. The window class styles, all that stuff we registered is all actually in here. You can see that there's no cursor registered, no icon registered, no menu registered, no background brush, all that kind of stuff. But the more interesting thing for our purposes now is if you right-click and go to Messages, you can actually see what the messages that are getting dispatched by Windows to us are, right? And now a lot of these we were actually expecting to get. So for example, if we go in here, you can see if I hit a key, you can see that it's having key ups and key downs get dispatched, right? And so that's all good. But what's kind of what you can see if you look at it normally is we're getting these NCHI hit test or NC hit test messages and set cursor messages, as well as mouse move messages, none of which we're responding to. And it's that set cursor message that we really want to talk about because that's the one that would allow us to control what the cursor is. Now, like I said, there's two ways you can actually do this. Another thing that's interesting about these, I believe you can kind of go in here and you can actually say which ones you want. Yeah, so if you go in, if you right click in here, you can click on logging options. It's a quick way to get, I think it's also up here. You can go ahead and get to the messages that you want to see. So you can kind of like highlight, you can see all the Windows messages in here, and you can clear and only select ones that you wanted to see if you were looking for particular messages, and that helps cut down on the cruft a little bit. Okay, so just something to keep in mind. Anyway, yeah, so that is how that works. We don't really need to use it for any particular reason here, but I just thought I'd bring it up in case you were having troubles where you might want to see that. What I want to do is I just want to start processing that set cursor message, and like I said, there's really two ways we could do this. One is down here when we register our Win class. So one thing that we could do, right, is we could say there's I believe it's H cursor, which is inside the window class structure when we register it. And then again, this is the thing that controls how our window behaves. Anything that's created with this window class, but we're only creating one window with it, right? What we could do here is we can load a cursor basically out of the default cursor set. And I'll show you what that means. So this gets into sort of these Windows minutia things that we really just don't care about very much as a game developer, but once in a while you kind of brush up against them. A real application uses all kinds of this stuff oftentimes, like an app style application that has lots of mouse interaction with that isn't custom, sort of standard Windows controls and all that sort of stuff. So basically this load cursor function, what it's normally meant to do is there's a thing called an RC file that compiles into a res file, which binds into the resource fork of your executable and all this other nonsense. that we really just don't care about for the most part. We will have to care about it a little bit when we want to actually make an icon for our game, so that when it's sitting there in Windows, you know, when you go to double click on it, it has an icon. We'll have to see how to do that. It's called a resource file, and we'll have to do that. But we're not doing any of that right now. So we actually don't have any resources, which are things like strings or images that get loaded out of the executable directly. Basically, this load cursor function would normally allow you to load a cursor by name using a string. Would allow you to load that out of your executable, one that you had drawn and baked in there using the resource editor, which is a thing in Visual Studio that would allow you to edit cursors and save them in there, right? We don't want to do that because basically we're not going to have a cursor except in debug mode. So all we really want to do is say whether or not we're in debug mode. And if we are in debug mode, we would want to show the cursor. And if we're not, then we wouldn't, right? Because the release version of our game should never show a mouse cursor of any kind, since it's not a mouse-controlled game. But the thing that I was talking about now is if you wanted to always show a cursor, what we could do is just load cursor here, right? And we need to pass our H instance, which we've already got. And then we just pass a constant, which would load some of the default stuff that you don't actually need to bake into your executable. That's just in Windows proper that it can load. And so like the standard arrow is IDC arrow. We could load IDC cross, for example. So here we go. Let's just put that in there as a simple example. And now when we ran the game, in theory, you know what? There's one other thing that I guess we would have to do. Actually, no. I feel like that should have worked. I'm a little surprised at that didn't work. Oops. Why didn't that work? That is very odd. So I guess I guess I'm just misremembering. I thought that if you put one in there and you called def window proc on set cursor, which we do, right? Because we don't handle the set cursor message. So the set cursor message will get passed through to here, right? I thought that would mean, oh, I know what I did wrong. This load cursor, if you use one of the things, it's going to try to load it out of this executable, but I just said we don't have any of these in our executable. So it'd be load cursor 0. If you want to load one of the default ones from Windows, you have to pass the null to tell it that you're trying to load one of the Windows ones. Forgot about that. Let's try that again. There we go. So that's what I expected to happen. So as you can see, this is a little XOR cursor kind of thing that Windows supplies as one of their default cursors. So now, inside our window, it will always be that. It won't just be whatever the last thing was, so you won't have that spinning anymore, and that's fine. But what I'd like to do is I'd like to be a little more explicit about it, because I'd like to be able to I'd like to be able to have it so that the game can dynamically control whether or not the cursor is visible. We don't have a debug overlay or anything yet, so we don't really have a reason to use that at this time, but I would like to be able to do that. And so what I'm going to do is I'm going to go ahead and and make it happen that way. So we're going to leave hcursor as 0 for now, and basically get rid of that sort of window class one so that it won't set it for us. So then I'm going to go ahead and get up, go up to the window callbacks here. When we get a WM set cursor message, I can do exactly the same thing that I was doing before, essentially, right? So I'm going to need this cursor. I don't really want to bother you. I think you actually could just call load cursor every time, because I don't think it incurs any cost. It doesn't like open a new handle to the cursor if you're just loading one of the default cursors. But at the same time, we have a Win32 state structure that we're able to access. So in theory, oh, and you know what? I wonder if set cursor can be intercepted the way we were doing it before. Well, so let's actually look at that as well. Let's take a look at this here. I'm going to put an assert in here. And then I'm going to go ahead and see if it ever gets dispatched in normal cases directly to us. Because again, this is for debug only, so if once in a while it didn't, that would be fine. But I want to see if we can intercept this guy, basically. So if we can intercept him, that would mean that we wouldn't have to have any state there. Nope, it looks like it goes directly there. So remember how we did this. I don't know if you recall. But basically, the way that we set things up is we have a thing that processes messages that go through our message pump, our message loop properly. Ones that we are actually dispatching to the window ourselves, that Windows puts on our queue. But then we also have our window callback, which essentially is the thing that Windows will sometimes just flat out call. And there's nothing we can really do about that, right? Remember, I talked about that. In theory, it's always supposed to go through the message pump, but it doesn't. I don't know why they ended up in such a hybrid scenario. It's kind of bad, but that's just the way it is. So it looks like our set cursor will have to happen there, which means we'll have to make our cursor a global. But that's fine. There's really no problem with that. So we can do a global cursor here, and we can basically say that the set cursor happens in there. Not a big deal. I just wanted to see if it was possible for us not to do that. So here's the global variable. We have an H cursor, and this is basically the debug cursor. And what we'll do is we'll go ahead and set that inside that set cursor call. We will use the debug cursor. In fact, I guess I should call it the global debug cursor. So debug global cursor, like so. And then I will call setCursor, which is the function in Windows that actually sets what the cursor is for our window, right? So when it asks us what the cursor should be, we can set what the cursor should be so that it will know. Now, what I would like to know, though, of course, is I want to know, it's been a long time since I wrote any setCursor code, so I just want to go through and read and make sure what the things are that Windows expects us to do inside this message when we receive it. And let's see what it says. So the def window, let's see. Sent to the window if the mouse causes the cursor to move within a window and mouse input is not captured. Okay, so basically we're just going to get this. The def window proc, blah, blah, blah. Pass the message to window. Yeah, it doesn't seem like there's anything particularly weird that we'd have to do here. So basically, if we wanted to, we'd just go in here. Set cursor. What do I have to pass for set cursor? Do I just pass set cursor? Do I not pass the window handle? Oh my, I don't pass the window handle. I guess that's just right. I guess it's just because you could be setting, there's a thing you can do in Windows where you capture the mouse cursor and it can move anywhere, but it still technically belongs to your window. So I guess it's not really a Windows-specific thing. I guess it's just kind of an ownership thing. So I guess when we get a set cursor, we'll just go and set it there directly. And that should set it to the debug global cursor. Of course, the debug global cursor hasn't been initialized, so at startup, when we do our win class, what we would like to do basically is also load that cursor. So I'll do a load cursor here, and we'll do that. We'll do IDC arrow, which is just the default cursor. So that way our cursor is initialized. Then, in theory, we should be able to do something where we actually get that set cursor to work. Although, we still had our wait. Looks like it's working now for the most part. But, yeah, I've got a few oddities there. I'm not sure why it was still looping. I'm not sure why we get the wait arrow when we first come in there. It still thinks our application is busy, which is a little odd. I don't know if there's some messages that we're not responding to there or something that's going on there. But also, it looked like we were doing that set cursor call everywhere, so we didn't actually get our sizing stuff right. So I wonder, yeah, I wonder what we want to do there exactly. I wonder if what we want to do is basically just let the default WinProc handle it so that it'll do the sizing stuff for us, and then we will only set the cursor to something if we need to. So for example, we can do a set cursor 0 in there, and in theory, I believe that would make the cursor not appear. Yeah, and so you can see if we do a set cursor 0, we basically get no mouse cursor at all, which is what we would want in a release mode scenario, right? So maybe what we would prefer to do is actually just do something like if cursor is hidden, or I guess if show, or like if debug show cursor or something like this, then we will actually allow the def winproc to handle it, otherwise not. So we could do something that looked a little like this, and then instead of having a global cursor, we just have debug global show cursor, something like this. There we go. There we go. So, you know, what I could do here is basically say, all right, we'll actually set up the cursor in our WinProc so that it'll basically allow Windows to do whatever random stuff it does, so we don't have to go figure out all the right stuff to do. So in here, we'll still do that where we actually specify a cursor. We'll load out the default cursor, IDC arrow, and then we'll just have our debug global will basically be debug global show cursor. And for now, I guess what we can do is basically say, you know, we've defined in our handmade platform.h, we've got our definitions for what's supposed to be, or at least I thought we did, for like handmade internal and stuff like that. Handmade internal. Did we leave those in here? Oh yeah. So this should actually be this should actually be in handmade platform, because that actually affects everybody. Just want that documentation there. So basically we said these were the things we were going to do. So if handmade internal is on, so this is an internal build, then we probably want that mouse cursor, right? We want to see the mouse cursor. And if we're building a release build, then we wouldn't want that mouse cursor in there, right? Oops. And then I didn't actually change this to a bool 32, which is what I wanted. So now when we do our build, in theory, we should have the mouse cursor work properly. I still don't know. I do not know why the little spinning arrow is happening there. I'm guessing we haven't done something that it wants us to do to let it know, so that it will know that we're done loading. And I don't know. Let's take a look and see if we can find out what that is. Let's take a look. Google. We want to know how does Windows know your app is done loading? No. So, yeah, Windows or Win32 cursor arrow spinning. Let's see here. I mean the hourglass, spinning cursor, display. I'm not sure. I might have to look this one up on my own, basically. So, essentially, if I remember correctly, unfortunately, I remember the circumstance, but I don't actually remember what the actual set of things is. My recollection is that when a Windows application starts, what happens is it assumes that the application is loading and uses that arrow with the spinning cursor. It uses that until you have done something, some set of things that it looks for. If you do any one of those things, it assumes that you've finished loading. But I don't actually remember what any of them are, unfortunately. And I'm guessing we just aren't doing whatever that is, right? So if that makes sense. And I don't really know. I don't know if anyone here has this sort of thing. Let's see. Yeah. Doesn't look like these people know. I really want a Raymond Chen post. Let's see here. Let's see. Wonder if I can just go ahead and say Raymond Chen. Let's see. Raymond Chen. Let's just do cursor. No, it doesn't look like I can quickly get it. Let's see. Yeah, I really want a Raymond Chen. Raymond Chen's site is awesome because he answers, basically Windows questions in a very thorough way that's usually very accurate. But yeah, so I don't know why it thinks we're still loading. It's okay, I mean, it goes away after a second, but really it should have gone away right then because there's nothing actually that we're doing. So I'm not sure why it thinks we need to keep doing that, that cursor. But I'm sure it's just a case of something where there's some call that it would prefer that we were making that we are not making. So yeah, so that's what I'm going to assume for now. I don't actually know, but we'll leave that as a to-do, and I'll see if I can find an article on it because I remember explicitly reading about that long ago and I've just forgotten. So we'll change this to make the right calls so Windows doesn't think we're still loading for a bit after we actually start. So there. Now, we can use Raymond Chen right now because full screen support is something that it would probably be nice to go ahead and put in there as well, which is that we don't really have too much of that going on because our renderer is kind of fixed to just rendering that little square at the moment, but we're going to want to start, getting away from that, especially when we start on the renderer proper. So one thing I did want to say was basically full screen Raymond Chen. This is, to give you an example since we were talking about it, let me see if I can find one of those. Here we go. So I believe this is a good article on that. I don't actually know if that's true. Let's see. Let's see here. Let me actually see if I can find. Yeah. So I guess that's the best one. I don't know. This doesn't look like the one that I was thinking of. I'm actually thinking of a different Raymond Chen full screen article. Let's find out. Let's see. Raymond Chen. Let's do switch. I want to show you because this is a good blog. It's a good blog to go on. I don't know if let's see if the Stack Overflow has a link to it here. Google's failing me today. I guess my Google foo is not very good. Here we go. This is the one I was thinking of, I believe. Yes, here you go. So basically, if we want to just put our window up and cover the whole screen, which is something that we might want to do, basically, this code is some probably verifiably decent code because it comes from Raymond, who actually works on Windows and stuff, and tends to have the right sort of answers to all of the crazy stuff that goes on inside Windows. Because obviously, there's just so much stuff in Windows, and it's often so crazy spaghetti in there, that the likelihood that you'll figure out how to do something like properly set a full screen window without doing something wrong in some scenario is probably unlikely. So if you can find Raymond Chen showing you how to do something, I highly recommend that you take his advice. That said, maybe this won't work. We'll have to double check. Even Raymond Chen is wrong sometimes, but I suspect that basically if we want to place our window at full screen, this is probably the best place to start because essentially he knows those internals a lot better than anyone outside like us is going to know. And so it's a good thing to look at sort of what he does. And so you can take a look at this routine that he suggests here, which is basically a toggle. It will toggle between full screen and not. And so the way that it works is first it goes ahead and asks what the style of the window is currently. And if the style of the window is the overlapped window, which remember is our style that we were using, which is basically a window that you just kind of generally, it's exactly this kind of window. It's this kind that you can move around and do stuff with. It's not full screen at all, right? If it's one of those, then he basically says, let's see what the monitor is, the primary monitor is that we're on, and let's save where our window is currently. So this basically saves the location of the window as it stands, and this gets the information for the primary monitor, which is, I guess what it does is, I want to say, we'll have to look at what that default primary does, but I want to say it actually gets the monitor that the window's currently on, and I assume default to primary would just mean if the window straddles two monitors, default to the primary one or something like that. I don't know, but we can check. Let's look at what that does. I don't know exactly what that flag does. Let's see. Monitor info, get monitor info. Oh, sorry, monitor from window is actually the thing taking that. Monitor from window. There we go. So that takes the window handle, right? And then, gives us back whichever monitor the window's on. But let's see. If the window does not dissect any... Okay, so basically if the window is not anywhere that it can determine what the monitor is, then it will do default to nearest, default to null, or default to primary. So obviously we want default to primary because we'd like to go full screen on something. Yeah, so that's fine. So basically, that's what that does, right? And then we go ahead and, assuming that we were able to actually execute those two function calls, we set the style to not have any of the bits of overlapped window in it. Remember, overlapped window, for those of you who don't remember, we actually did this before. Overlapped window is, ooh, you could jump right to window styles. Look at that. Thank you, Google. Overlapped window is actually an aggregate. So you can see it's actually overlapped caption, sys menu, thick frame, minimize box, maximize. All the things that sort of make a standard window, all those flags are an overlapped window. So basically what he's doing is he's saying, let's clear out all of those. They're gone now. We masked them out. And then he's going to call set window pose to basically change it to be the size of the full screen, right? And he's saying don't change where it is on in the Z order, so don't raise it or lower it. And then give it a notification. That's what these flags do in set window pose. Give it a notification that its border, that it's like this part, it's sort of external to the client area, has changed and needs to be redrawn. Assuming that the thing was already full screen, which is what he's doing in this case, he does the opposite. He puts those overlapped window things back in. he sets the window back to whatever the last place it was, was, and then he goes ahead and does that set window pose to update again. The set window pose is basically a thing that, it's weird that there's set window placement and then you have to call set window pose. That's just how ridiculous Windows is. Basically, when you call this, it doesn't actually do the repainting necessarily for you. So you have to go ahead and do this to get your frame to repaint properly. Windows is full of horrible stuff like that. That's just the way it is. It's why you have to look at people like Raymond Chen to find out how to do stuff properly, because the chances that you'd figure out these exact incantations are like nil, right? So there you go. So in theory, this should work, I believe. And so let's go ahead and try it. Like I said, I trust Raymond, so I think that this is probably a good way to go. So we'll go ahead and do essentially exactly what he says. For all intents and purposes, we might make a slight modification here or there, but for the most part, we're going to just exactly copy what he does, because like I said, he knows much better than we do. So global window position, something like this. And he wants it to have that size of there, so that basically would be, I assume that the reason he's doing that is just so he can use it even if it wasn't initialized yet. I'm not exactly sure why. But yes, I guess when you call, you have to give it that size. When you get window placement, probably requires that size is there. All right, so we basically now have a thing which is like toggle full screen for now, and we might make this a little more complicated later. I don't actually know why I guess he was doing it in a message pump kind of a thing, but that X and that Y aren't used, and neither are the key flags. So really that doesn't have to be there. Really all we need to know is what the window was, right? And so we're going to go ahead and get that back, get that style back. Not a big fan of Hungarian, so I'm just going to go ahead and kind of clean this up so it doesn't look totally out of place. And I might also, while we're at it, snap that who we got the code from, right? This follows Raymond Chen's prescription for full screen toggling. See there. So that way, if people are wondering what's going on there, they can basically go, oh, okay, let me go read Raymond Chen's article about it and see, why Casey thought that this was the series of steps you're supposed to do. And I'm like, just following Raymond, man. So anyway, we've got the monitor info stuff going on here. He initializes oops, I don't have size up there. Okay, monitor info. Again, we initialize it with the size because Windows loves to have us put the size into structs ahead of time for no real reason. I think they thought that would increase compatibility. I doubt it ever did. Anyway, let's go ahead and finish up that there. We need to go ahead and put in our global window position here, like so. And we need to get our monitor info like that. Then our set call should be fine. Basically exactly what he was doing. Style, there we go. And there we go. HWind top. Let's see. RC monitor left. So these are just in the monitor info structure. He's basically just using that monitor info to figure out how big the screen should be, which looks like a good idea to me. That will give us the full screen. And then we just have to do the case where we want to set it back. So there we go. Window. Oops. Window. Wow. Not typing very well. Window. And we're going to restore that placement here. So this is that global again, the window position. And this is just the thing that has it redo the positioning. Okay. So in theory, that should do our full screen toggle. So I'm going to go ahead and put that down where we do our processing, our keyboard messages. Let's go ahead and do that. And so really all I want to do here is I want to call this on a particular key message, right? So I want to basically be able to toggle the full screen when I do a particular key message. And in this case, what I want to do is follow the old, since this is mostly a debugging thing, normally the user wouldn't be hitting a key to toggle full screen. I'm going to use the standard, the Windows standard key for it, which is a bit obtuse, but it is what it is. So I believe we handled Alt F4. The standard for this is actually, if I remember correctly, it's actually Alt Enter, right? So it's basically, I don't know what I don't remember what the VK code for return is. I don't know if it's enter or return. But if the Alt key was down and they hit return, then I'm just going to call that toggle full screen function. Assuming this also, I always forget to use is down in here, right? I always forget to use or basically went down, right? I always forget to put things in there. And so these should also be in there because we essentially only want to ever do this stuff on key down. We don't want to do it on key up as well, because otherwise we'd trigger twice, once when it goes down, once when it comes up. Window is undeclared. Oh, well, yes, that's true. We want to do it on the window that was coming in here. What is it, hwind? There we go. Yeah, I need to get it out of the message structure because we're not actually in a window handle. And I guess I could also say make sure that is valid. There we go. Like so. So let's take a look at what we've got here. Looks like I'm still doing it. That's right. Never learn, will I? I've done this every time we've added key bowler handling. I forget to do it only on the down. All right, there we go. So there we go. We now go full screen just fine. And so the reason I wanted to do that, of course, was because I feel like later on down the road, we're kind of going to want to have it so that we can switch to full screen and have the renderer do rendering of full screen, even though we'll be horribly slow in software because it's too many pixels. We'll want to test, doing that sort of stuff. So I just wanted to kind of throw that in there. It's really simple, like I said, as long as you have an expert to guide you. When Raymond Chen writes about something, it takes a lot of the pain out of Windows because you can just, what he says works. Like he just really knows that stuff better than anyone else. And so you find something on Stack Overflow, it's probably wrong, and you'll go be super grumpy and tear your hair out. However, if the Stack Overflow says, here's what Raymond Chen says, just click on the Raymond Chen link and you are done. Like you can pretty much count on that being a pretty solid answer. All right. So, so that's all good. I should mention a couple caveats there. There are caveats that I don't mind, but other people might. So there's multiple ways to go full screen in Windows. I'm doing the one that I prefer, but it has downsides. So the reason I prefer this way is because I find it's a lot more stable. And it doesn't cause weird monitor flashing, and it doesn't cause your HDMI to lose sync and that sort of stuff. But it has some downsides. One downside is you can't change the refresh rate. Now that's not a particularly big deal these days because you really shouldn't be changing the refresh rate on the monitor probably. Whatever the users was set to is probably the one that you want, but maybe they've got it set to something wonky, I don't know, and you want to try and set it to 60. If you think the monitor can handle 60, you could enumerate the modes and do it. So there are other things that you could be calling, right? For example, change display settings. I just want to point this out. Change display settings is what a lot of games will call. Change display settings actually allows you to be much more specific about what's going on. And so after, you would basically do this first. You'd call change display settings, and you would pass a bunch of stuff like what the resolution is that you actually wanted the monitor to be in, right? And then you would still do probably what I just did, follow Raymond Chen's advice, but you'd first call that change display settings. And so sometimes you have to do that if you have other concerns, right? Like basically, we are running the game in whatever mode the user has their monitor in, right? And usually that's okay because what you can do is you can just have the GPU stretch you. Like even if we were only going to render at a small resolution because we can't, like even let's say we only run at 1080p even on GPUs or something, and the user is trying to run at some 240 by 2400 by something, or a 3K, 4K display, something like that. Usually what you want to do is just stretch up to that, because the stretch split is usually fast enough, even on those large displays, to compensate. But that's not always true either. Sometimes on some things like Intel integrated graphics parts, the GPU is just horribly slow sometimes, and it can cause you problems, and you really do want to set that display mode. So it's just worth noting that pretty much anything that you're going to do can has some potential negative consequences to the user. If you really wanted to be fully complete, maybe you would even supply both as possible ways of doing it, and you'd try to detect. like you'd go, oh, we did the switch, we do it this way, and then if the frame rate's too slow, we try changing the display settings down if we detected the blitz too slow. And maybe we can try doing this on that stream. I don't know. At this point, that really shouldn't be a concern. That's more for older systems, but you never know. And so it's just something to be aware of. I want to mention it. I don't want people to think that there's no downside to doing it this way. It has a lot of upsides doing it this way, but there is a potential downside or two lurking in the shadows. But anyway, you can see if you implement it this way, it's much nicer because it just goes instantly and there's no weirdness, right? And so you really want to do this method if you can get away with it, and you really only want to do the change display settings if you can't. That said, maybe we should eventually implement the change display settings, and I'll put a to-do to that effect, and put in a detection thing where we detect, wait, our frame rate's really slow and the blitz taking all the time. Let's see what we can do about it, right? So let's do change display settings option if we detect slow full screen blit, just so we've got that in there. All right, so let's see. We took care of our set cursor situation, and we have our full screen situation going on. So I think that's good. And so really all we'll have to do eventually is decide what we want to do render-wise in terms of who gets past what. So when we get a little bit further down the road, this will be good because now we've set ourselves up so that when we want the renderer to start responding to that full screen, we don't really have much work to do in the platform layer. It'll just kind of work. All right. So that's good. Yeah, that's good. I think that's a good thing. Another thing that we could do, I guess, real quickly, I don't know if this is what we want to do long-term, probably not. But in terms of stretch DI bits, what we could do too is something kind of a little wonky where we basically do some kind of an if, where we do, if we are in full screen, then do that stretch blit. Like if it turns out that you can do a perfect 2x, do the perfect 2x, and that code would be pretty trivial, right? That code would be something that kind of looks like this. Let's say we did something where we said, if window width equals, oops, I should probably put this in the else case, just showing you kind of a simple thing here. This is not what I think I'd want to do eventually, but just to throw it out there. If the window width equals the buffer width times 2, right? Because we know we were currently doing a downsampled by 2 thing. So this is just some hacky code to put in here just to show you, an example. So if we happen to have exactly 2x display, then go ahead and do the full-on blit, basically. So I believe we just want to go ahead and say offset x, offset y is going to be 0 in this case, and then the window width and the window height. So just do the full blit up. So if we do that, then we'll still run the way we normally run when we're in this mode, and when we're in this mode, we'll get full screen, right? And it'll basically just do an upsampling by 2, which is a totally fine upsampling and shouldn't cause us any problems. So, for the time being, that's probably fine. Basically, that allows us on 1920 by 1080 displays, that allows us to do it. In fact, we could go one further, which is actually saying, in the case where it's greater than or equal to it, we'll allow it to happen by basically saying we'll just enforce that it's always 2x, so that we basically don't have any weird scaling, because stretch DI bits doesn't do particularly good scaling, if I remember correctly, so we wouldn't really want to do that. But in this case now, if you're resizing the window, right, and you don't have enough room to do a perfect 2x scale, it won't do the perfect 2x scale, but if you do happen to have it, it'll do it, and that'll work. I'm on a 1920 by 1080 monitor right now. If you were on one now that's higher than that and you went full screen, you'd just still get it up in the corner. I guess we could be even a little bit better than that. We could even do it centered. I don't know that necessarily matters particularly much. But, like I said, later on, maybe we'll fuss with this a little bit to do Casey. Centering black bars, that sort of stuff. We could make this, we could spend a bunch of time making these sorts of things better. But basically, we're out of time on the stream. We've sort of done the stuff that I had wanted to do today. There's a couple other things that I would want to maybe do in terms of Windows cleanup, but we'll just roll them into times when we are actually working on that part of the code. Like basically, there is one thing that I want to do with the replay code that we didn't get a chance to do. So anyway, there we go. There's our little dude. He's having a good time, as you can see. He is very happy and cheery, which we like. And so, yeah, I think that's a good place to call it for the day. Because we are right about at an hour. I think I started about 6 or 7 minutes late. If you want your game to be full screen, how would you want to handle screens with different aspect ratios? So I don't know, and we'll have to do some work at that. We'll have to make that decision. I don't really want to deal with it right now because it's not that relevant to what we're doing, but it's a good question, right? If we were to play on a 4:3 display as opposed to a 16:9 display, what do we want to do? Do we want the player to see less of the screen and have to just deal with it and be like, hey man, if you wanted more field of view, you should have gotten a bigger screen? Or do we want to put like bars on the screen so that they get a letterboxed version? I don't know. And that's just a decision that we'll have to make. But it won't really affect our renderer. That's the aspect ratio is something we're able to play with a little more freely. So that won't really be a problem for us. We can choose to do different things in the future. So here's where we were at. We left off on Friday. We had fixed our perspective transform, and you can see that we're not drawing a ground right now so that we can see actually the tree rings that go increasingly back into the distance, so we can see 3 levels of the world. Now, it actually goes much further than that, the world does. I think it goes, I don't even know how far it goes down, but very, very far. I want to say it may go 2,000 rooms deep right now. I'm not sure if I'm right about that, but I think we may generate 2,000 rooms straight down. And what we do right now is we actually have some little simple yellow rectangles here that we can walk down, right? And we walk down them, the top level fades out and a new level fades in at the bottom. So we're totally set with how that works, and the perspective is looking pretty correct here. Our renderer is completely unoptimized right now, so it's still a bit slow, but that's totally fine because that's something that we'll be getting to sometime soon anyway. So what we need to do now is we need to have a little bit of a more coherent idea about how we're handling these Z levels. We wanted to quickly check the perspective map just to make sure we didn't have anything weird in there. I was a little nervous about the actual values we plugged in for our monitor distance and stuff into our math. So we want to take a little bit of a look at that, but what we would like to do after that is just get back to the issue at hand, which is figuring out how to represent these Z values in terms of storage and in terms of other stuff so that we can kind of get, just a better feel for them. So I guess one thing that I would like to do now is just say, all right, let's take a look at that perspective projection and let's think about what we're actually representing in the world here and how we want it to appear, how it should appear in terms of how big it actually was, and we'll see if things make some sense. Now, I agree that the way that I've tuned it here is probably not super realistic. If these are actually stories of a building, you have to figure that probably they'd be a little bit more separated than they are now, right? And so probably I tuned it a little conservatively, and so really it's not maybe as bad as I made it out to be, but I think it still is a little wonky, so maybe we'll take a look at that. But let's go in here. Let's say we switched it to something a little bit more like that. That looks a little bit more correct to me in terms of maybe if it actually was sort of more like the story of a building like it's supposed to be. We set it to 3 meters, which is around 1 story height for a building. Certainly not cathedral ceilings, but something that's a regular height that should actually be right. And that probably is a little bit better than it was than I had it tuned, right? But looking at that as a set of parameters, right? If that looks particularly reasonable, backing out what's in here, right? What we're essentially saying is kind of weird. Like, what this is saying is that the camera distance above the target, which is the place that we're looking at, the camera distance above the target, we're setting it to the same thing as the focal length, right? And I guess, I mean, that could be a reasonable, that's the thing that was weirding me out, basically. That could be totally reasonable. So let's take a look at this here. Let's think about this for a second. So basically, meters to pixels is used in only really two places now, if I remember correctly, right? I believe that meters to pixels is essentially used only to compute our actual projection, which is where we want to use it, but also in one place where it's kind of annoying to have to use it, but it's basically where we compute our bitmap offsets, right? And the reason that we need it there is because our bitmap offsets are in pixels, because that is how we know, like, that's how we measure them, right? So there's a couple ways that we could try and mitigate that fact. In fact, there's a couple ways I can think of right now to mitigate that fact. So maybe what we should do is try to get meters to pixels out of the pipeline entirely by converting the values that we currently need it for into something else, if that makes sense, right? And if we do that, then we can set our perspective transform up so that it's the only place that thinks of ways I can think of right now to mitigate that fact. So maybe what we should do is try to get meters to pixels out of the pipeline entirely by converting the values that we currently need it for into something else, if that makes sense, right? And if we do that, then we can set our perspective transform up so that it's the only place that thinks about how pixels and world units interact, and the rest of the game never thinks about it at all. I think that's a pretty important thing to want to do, because that way it makes it easier for us when we go to start supporting multiple resolutions at the same time. It makes it so that that's not some big ordeal, right? We want to be able to just say, okay, if we want to change the resolution to 1920 by 1080 from our, from our current resolution, it's just a simple thing to do, and it's not this big sort of ordeal where we have to think about everyone who's thinking about pixels, right? We want basically as few people as possible ever thinking about pixels so that we can be resolution independent up to as far of a point as we want to be, right? So what I'd like to do is I'd like to go ahead and suggest that perhaps we just encode our hotspots as being proportional to the size of the bitmaps themselves, right? So instead of having them be proportional to this meters to pixel stuff, instead we can just have our bitmaps not have any of that information, not have any of that sort of concept at all, right? So if we take a look at handmade render group, right, you can see how we've got this V2 align right now, and right now that's in pixels, right? But what we could do here is we could sort of say that, well, what if that was a line percentage, right? So the loaded bitmap was actually saying what its alignment point was as a percentage of its width and height. That way it can be passed through without ever being multiplied out, right? It can always be in some independent thing that will be the same whether the units are meters or pixels or anything else, right? Because a percentage of a distance is the same whether you're measuring it in pixels or measuring it in anything else, right? So if I was to change this to a line percentage, let's see what that would do to the code, right? So when I am doing this sort of operation here, where we're like, okay, meters to pixels, offset, and then we have a line, whatever. When we do our push bitmap call, in this case, I believe that we never actually at this point specify how big we want that thing to be. So, okay, this is going to be, I think this might actually be even more interesting. So this is all good. I think I'm feeling good about this. I think this is probably what we should do. So I'm going to go ahead and go down this road. There's two steps we need to take, and I'm going to see about taking both of them. So the first step is to extract out that alignment, but it's still going to introduce one thing that has to do with meters to pixels, and you'll see that in 1 second, right? So what I want to do is introduce the alignment here. So what happens if I was going to do that? If I want to pull this alignment out as alignment percentage, I need something to multiply it by, right? So I need to make this alignment like so, and my bitmap align percentage here, I need to multiply it by something that is a reasonable percentage, right? Now, since we're still in pixels everywhere, I actually know what that percentage is supposed to be. It's supposed to be in pixels because this is accepting pixels right here. So what I need to do is say, all right, I just need the bitmap width and height, right? And then if I multiply the percentage, the align percentage by that bitmap width and height, that will give me where that alignment point is, right? So let's go ahead and take a look here. What did I do there? Bitmap align percent. Oh, right. This is a Hadamard product, right? It's a vector product. Let's go ahead and do that. So when we do this this alignment stuff here now, we got a little more work to do. You can kind of see that we've got a few places. Just there's not very many, but there's a few places that set this alignment. So now these things, what they have to do is they have to basically be smart about the way they encode things. So right now we've got this alignment. It gets passed in. But it's not a proportion of the width and the height. So in order to do that, what we want to do, I believe we have a safe ratio function. Do we not have a safe ratio function? I'm going to take a look and see if we do here. Safe ratio, we do. So I'll do safe ratio 1, let's say. Well, actually, we'll do safe ratio 0. So safe ratio 0 and produce a ratio of these where we encode the x and the y based on that bitmap width and height, right? So it's the same alignment value. It's just instead now we're changing it to mean the percentage, right, of the width and height, okay? Hopefully that makes sense. So let's take a look here. We've got, okay, these guys have to be up. In other words, what I want to do is say, okay, you know, we've got a thing, which is like y, x, like this, right? And what I want to do is say, okay, from now on, we need to actually say how big things are going to be on the screen. We're going to give those in actual meters from now on. So when we say how tall the guy is, we're going to give that in meters, right? We're going to say how tall the guy should be in meters. So when we do that, what I'd like to do is say how tall he is in meters in one dimension, right? Like y, I'll give the y value, and then it'll solve for the x value, right? Well, not solve, it'll compute the x value based on a multiplication knowing what essentially the aspect ratio of the sprite is. Meaning I'll say whatever the x pixel width is, right? Well, I guess we'll do it this way. Pixel width over pixel height will be something that we store with a bitmap. And when we do this, right, the fact that this is in pixels, right, it's like 32 pixels over 60 pixels or whatever, pixels cancels out, and we end up with just a dimensionless ratio, right? It no longer cares that it's in pixels. And so again, that will help me to eliminate pixels entirely from the pipeline here by just specifying that and getting back to sort of a pixel neutral way of specifying things. So let's go ahead and take that step, right? And let's say width to height, right? Or I guess we'll say width over height, right? Something like that. So it's just a scale value that says if I have a height value, I can multiply by this to get the width out of it no matter what it is, okay? So what I need to do now is every time we actually load a bitmap, I need to go ahead and compute that value. But that is not very hard to compute, right? It's just a simple ratio. So every time we do a debug load bitmap, it's pretty trivial for us to just go ahead and store that value, right? Width over height is just going to be a simple ratio. Well, in fact, I'll use safe ratio 1 for now. I guess, well, 0 is probably better if the well, it doesn't really matter. That there should never be a bitmap that doesn't have both values being greater than 0, right? So what I want to do is take the ratio here, the result width and the result height, take the ratio between the two and produce that value. And so then that will give me a permanent way of doing that computation, right? And again, I guess I got to upconvert those to floats since they're by default integers. Once I have that, now when we go to do our push bitmap calls, right? Instead of the old days where we had meters to pixels governing everything, what I'd like to do is just say, okay, from now on, what we're going to do is we're actually going to say how big we expect things to be, right? How big in meters we expect them to be. And we can actually, when we load things, if we want to keep our current way of doing things, right? If we don't want to disrupt the way we're doing it now, And we essentially want to base the size of everything off of how big its bitmap was, which we probably don't really want to do, but you know, we could do that. We could say it's like native height value or whatever is based on that meters to pixels value, right? So we can still keep the old meters to pixels in here if we want to, right? Which would just be the native height of the bitmap. And that's just going to be whatever the height was divided by meters to pixels, right? Or more explicitly, pixels to meters times that, right? And that would mean that this, when we do that read, right, whenever we read a bitmap, we would have to say what we want our pixels to meters to be. But what I think we can do now, if we do it this way, is we could make it so that literally the bitmap loading routine is the only thing now that ever cares about pixels to meters at all. So what I'm going to do is I'm going to go grab meters to pixels right here, and I'm going to go ahead and go back up to this function and just paste that in here. So I'm going to say pixels to meters right here, and I'm going to say that that's, you know, right there. That's so for every 42 pixels, there's a meter, right? Which I think is probably not how big. I don't know if that's how big we want it to be. Maybe that is how big things should have been. I'm not sure. I don't remember. We'll have to think about that. It seems a little odd, but well, doesn't matter. Never mind. Ignore that for now. We'll think about that for a second, a little bit later. But let's say we go ahead and do that. We now have everything that we need in order to basically do this completely without any values in the pipeline at all. So let's go ahead and take a look at meters to pixels and where that is used. Right, you can see that essentially it's really something that's basically only used in the render group, right? We will leave this guy just in here. And what we want to do is we eventually want to set this based on what the renderer thinks you can see. Do And really, there's two sort of ways that we could do this. One way rolls them both into one multiplication. Another way does a transform to a unit cube and then out. And I don't know that we really want to talk about that too much because it's not super relevant, but I'll mention it briefly just so those of you who have 3D aspirations will kind of know what I mean. So when you're dealing with 2D art, you have a lot of advantages, which is that clipping is not a particularly difficult thing for you. Clipping is actually relatively trivial, and it's essentially something that is very hard to go wrong. You can essentially do something called guard band clipping for mostly everything, and the culling is very straightforward. You don't have angled things. Just a lot of things go your way. In 3D, you don't actually have that luxury, and so what they typically do is they use a thing called the unit cube, and they clip to a 4D unit homogeneous cube, okay? What this thing is it's basically, you can imagine it just the 3D part of the cube, actually. It's all good, right? Let's go in here. You can sort of imagine going to a unit cube, right? If you wanted to do clipping so that you could figure out, like, all right, here is the shape of the monitor, let's say. The monitor is always going to be this front face here, right? This face right here. This is the monitor, and the entire world fits in this unit cube, okay? So everything in the world has been shrunk down, aligned, and squashed into this unit cube. What typically happens in 3D projection is that you do actually do exactly that, right? You have some notion of the camera, right? You have the world out here. You take the frustum that you can actually see of the world, okay? This is the near clip plane, and this is the far clip plane, okay? You take this frustum and you literally warp it so that it fits into this thing, right? This part, right, comes out to like there or whatever, right? Over here, you know, this part right here comes out to over there or whatever. It's, you know, kind of gets maps in here. And the clipping happens now in this uniform cube space. So this part gets, you know, thrown out and this part gets kept, right? And the clipping happens to produce the correct fragments that should happen. The triangles as they need to be clipped are actually clipped in that unit cube space, okay? So all of the coordinates that you have when you do your projection, when you actually do the matrix, the projection matrix, when you actually do essentially this step right here, all of your coordinates are actually between -1 and 1, right? So x, y, and z are all between -1 and 1, or if you're in direct 3D, there's actually, it might be between 0 and 1, the z value. They did some stupid stuff. But anyway, assuming you're in OpenGL, it's all between -1 and 1. So first you do this smush, then they do the clipping. Again, this is done on the GPU. You're typically not doing the clipping. You just provide the projection matrix that does this smush. So you do the smush, the GPU does the clipping, and then the GPU blows out these -1 to 1 coordinates into actual screen coordinates, right? So it multiplies by the pixel width and height, right? And adjusts for the fact that the center was here and now the center is going to be down here. So it actually applies an offset as well to actually figure out where the pixels are, right? And so basically there's like this concept of first you do the smoosh, right? And then you do the blowout, right? That's not what they're called. This is typically called like view to window transform or something like that, right? Or you know, like clip space to window space might be another term for it, right? This, however, is called the projection, certainly. This is the projection matrix that does this, et cetera, et cetera. So that's basically the capsule overview. Now, we don't have to do this step. There's really no reason for us to care about this at all. It's really just not something we're going to have to worry about. So what that means is we don't actually have to do the smoosh. We can just have one value, because if you think about what the smoosh does, essentially there's a meters, world units, there's a world to unit cube transform, and then there's a unit cube to pixels transform, right? And so there's two scale factors. There's one that transforms the world into the unit cube, one that transfers the unit cube into the pixels. What we can do instead is just do world to pixels directly, and that's why we could, if we want to, and I think we probably should, just to keep things simpler, just have essentially a meters to pixel value like we did, right? We should just be able to use one value instead of splitting it into two values, even though that mirrors more what happens in the 3D pipeline, because we really don't care, right? We don't care about that in the 3D pipeline. So, okay. So let's say we want to do that, right? Now, maybe that's a bad decision, because maybe when we go to do the OpenGL path, we'll want to, we'll want it to be done more symmetrically on both sides, and, we'll cross that bridge when we come to it. For now, I don't think we really have to. Meters to pixels here. Why is bitmap still doing it? Works just fine with them. Or actually, you know what? Are we actually using that? We're not using that right. They may be busted, now that I think about it. We got to go in and let me fix that there. Let's see. I don't think they're busted, though. I think everything's fine. So right here, where we do this basis scale, bitmap width, and bitmap height, this I really just want to now use the scale value that we had in there originally. I probably should have said scale. Maybe we'll change that name in a second when we start to clean these things up. Entry size.y. There we go. So let's take a look here. Draw rectangle slowly. Oh, right. Sorry. Did that a little bit stupidly. There we go. What I actually wanted to do was put it here. All right, size.x, entry, size.y. Now, I don't actually know. No object file generated. Right, this is not a v2i anymore. It's just a v2. Don't actually know if that's all good now. Okay, so our I love when they get tiny. They end up moving so quickly. Okay, so now we have to go in and actually debug what I just did there. But we're getting a little closer. We're getting a little closer to having meters to pixels out of the equation, which is what I want. Hello, GIMP. No rush on the loading there, GIMP. Take your time. So yeah, so there's a big old empty space at the top of his head, too. And at the bottom, too, probably, actually. So if we take a look at where the torso ends, right? There's a big old empty space there, too, actually. So really, this guy is, unfortunately, not at all the correct size in the bitmap. So I don't know how we want to handle that at the moment. But basically what that means is that he needs to be synthetically scaled up a bit from what his actual size is, right? Because it looks like he's about an extra like third or something like this, right? In addition to where he should actually be. So that's more like it. And that actually does look relatively reasonable, right? That looks like he's now more or less the right size relative to the tree, if that makes sense, right? That looks like how big he should look near to a tree. Now, I don't super love that, right? If that's how big he actually should be, right? I don't super love how big he is relative to the tree. So I think we want to cheat that a little bit. I feel like we want that him to be closer to the size of an actual tree, because that's the aesthetic of a 2D game. So I feel like we actually want like a hero size coefficient to be, you know, some kind of a erroneous value here. Let's go ahead and... The number of pixels on the display is going to determine how many pixels a meter maps to. So what I'd rather do is say how big a meter is on the screen, right? So what I want to say here is actually a different value. I want to say something like monitor width in meters, right? Something like that. And I want to say monitor width in world units might be the better way to say it. So how big do I want the monitor to be, right, if it was measured in the space of the world? And so how many world units across is that monitor going to be, right? And I think what I want to say is that, like, okay, if there was something that was, you know, taking up a certain amount of space on the screen, on the, and I'll just take a little bit of time, just a baby bit of time from the Q&A to show what I mean by that, right? So assuming that I have it work like this, right? So now that it's based on that value, what I'm kind of saying here is, let's suppose that we were to change the dimension. Like, it looks like this, right? This is what it looks like, okay? And suppose that I went to go and change the dimension now to some other dimension, right? So, you know, let's say and in fact, let me do it the old way. So I'll just set it to 42 here. And here's my guy, right, at 42. Okay, and you can kind of see, like, you know, we're playing the game and we got how many trees across? 1, 2, 3, 4, 5, 6, 7 trees across, right? So then I go into Win32 Handmade, right? And I say, okay, instead of that, I want to change the back buffer to 1920 by 1080. We're going to use a high res here or whatever, right? It's just going to be high res. So we'll restart the game with a different back buffer, right? And now you can see it's like it's a different game. Right? I can fit all the trees. Across, and instead of only 7 across, I can fit 8 across, and then probably 9, 10, or whatever. Right? So what I wanted to do instead of that is I wanted to say, all right, let's make this based on the actual size of the screen, so that no matter what the resolution is actually set to, you know, it will work. Right? So if we go in here and we say, all right, that's how big it is now. Right? If that makes sense. If that's how big it is, you can see we can get 1, 2, 3, 4, 5, 6, 7, 8 of these on, and we don't quite get to that 9th there. I'm sorry, 7 on, and we don't quite get to the 8th. The 8th just kind of comes on as this one comes off, right? If that's the value, that's at 1920 by 1080. If I then go ahead and change the resolution to be back to a different value, right? The old value that it was, the lower res, right? I want this to basically be the same value. And so where are those trees? Let's see here. Can we get them to the right thing? Let's see here. 1, 2, 3, 4, 5, 6, and there's a 7th. Oh, but it should have been 8, right? So are we still a little bit off? I feel like that's still not quite right. Let me make sure. 1, 2, this is the topmost trees. 1, 2, 3, 4, 5, 6, and there's the 7th tree, right? Go ahead and put this back. What is, hold on a second. 1920 divided by 2. Oops, that's not right. 1920 divided by 2 is 960. 1080 divided by 2. These are correct, right? Just want to make sure I have the aspect ratio correct as well. Okay. Let's go back up to the high-res version. There's the actual trees. So yeah, it's still not quite correct. Oh, yes it is. We just can't see the end of the bitmap. 1, 2, 3, 4, 5, 6, and then there's that extra tree. There's just barely that beginning of it, because we can only this is a full 1920 by 1080. So there we go. And then if I go ahead and switch it back down again, we should have that exact same thing, right? And we do. So that's good. So we're getting there. We're getting there slowly but surely. Okay. So if that's our meters to pixels is computed that way, right? Our meters to pixels is computed there. Then the only problem we really have here is that, you know, we probably want We've got pixels to meters being computed here as well. So what we want to do is make it so that it's at least uniform there. So we'll go ahead and pull that out. We'll say that that's happening right here. So we have meters to pixels, and then we have, you know, pixels to meters. So towards the end when packaging, will you show us compression methods and ways to package all the art assets in one file? Packaging all the art assets in one file, yes. Compression methods, probably not. We'll probably do just a basic, like, zlib style compression. We probably won't really go into in depth on, like, okay, if you really want to do compression, here's how to understand, like, all compression stuff, and because I'm not a compression guy. So we'll probably do some pretty basic compression, basically just an LZ compressor, and that'll be all that we'll do. And as for whether this game's going to be 2D, 3D, or isometric, it's basically like 2D art, but it's fully 3D in terms of like how we're allowing the world to work. And we're just doing that to basically show how you can robustly program the 3D-ness so that we don't, so that people kind of can get a little bit of that learning. And I should do as well. Just until we actually do that UI. I'd like to make that debug menu a little bigger. Radius, 400. You know what? That also should be the square. Because we're taking the length squared and we should compare it against the menu squared. But that's for tomorrow. So there's our actual UI stuff, right? Okay. So if I go ahead and get the dude in here and set the looping. So now I'm looping, and now I can get the UI happening on top. So I think I should be able to do something like if I want to change the ground checkerboards, I think it just works. And yeah, there it is. So that's fine, and I can do whatever else I want. So I can make the familiar follow the hero, and there he goes, right? I can And I don't know if you noticed, but of course. course, when I implemented those, I didn't do anything unusual. I didn't create some giant UI hierarchy. I didn't go Qt on it and have 800,000 classes just to implement a button. All I did was I put an if statement into the code that said, if you are hovering over this rectangle right now, and it becomes the like hot rectangle, and if you click the button, then it executes some action on that rectangle, right? That's all I did. And that is the attitude that I think you want to take for making debug UI in a game. You want to make the thing that is the easiest to implement, that doesn't cost you any time, that doesn't lead to like code rot or anything, that just is nice and tightly bundled with the actual output code, so that the rendering and the UI line up nicely, and so that you can expand on how you're rendering things and trivially have the UI kind of follow along with it. All of that sort of stuff is really what you should be shooting for. And that is exactly how we are going to continue progressing down sort of that path of implementing this debug UI up to the point where we feel like it's good enough for us to use on the project. So we're going to take a slight step back from what we were working on last week because I kind of just shoved some things in at the end because it was kind of wrapping up the week. We're going to take a slight step back. And what we're going to do first is say, all right, we need a little bit of debug UI here. The very first and most obvious thing that we should probably do before we go any further is have a way of turning this profile view on and off, right? Because right now, if I go run the game, right, let me just bring it up here. We now have profile bars all over everything, and we were playing around with those, and that was all fine. But the problem with that is that we can't see the game, right? So at the very least, we are going to obviously need some way of saying whether we want to draw any of this stuff or not. Because if we are in a situation where we're working on the game and don't really care very much about seeing profiling in detail or any of that stuff, then either A, we want the profiling to go away completely, like just gone, or, we also probably would want to consider something like a collapsed view that's just a very small, sort of extremely small debug monitoring version that just sits in the corner and is designed to only draw whatever is necessary to alert us to a potential problem that we might have missed. So for example, frame spikes or things like that, just show the total amount of time for the frame retirement. Maybe it goes in there so we can just say, oh wait, we saw something weird happening there, so that we can go grab it, right? Something like that. So that to me is more, what we want to focus on. So I want to start putting in a more solid concept of the debug rendering stuff so that we can get to the point where something like that is nice and achievable, and we have a solid story for how adding things to that UI kind of like comes in. And you'll notice up to this point in Handmade Hero, when we had debugging features and things like that we wanted to implement, you'll notice we also kind of had this problem of they just kind of always had to be shoehorned in there, and we never really had a good way of like turning views on and off. Now, that may not be such a big deal, actually, if you think about the fact that we have live code editing ability, but there is a problem, there is a shortcoming coming with live code editing ability. While live code editing ability does totally solve our problems in terms of like tuning a particular piece of code, because we're working on that particular piece of code at that particular piece of time, at that particular time, and it all makes sense, live code editing doesn't help us if we have a number of different debug, like visualization kind of things that we might want to turn on and off. For example, if we want to draw like entity bounding boxes, right? Yes, I could make that be just a live code editing thing where I just go back into the code, right? I change the entity bounding box thing, and then I come back. That's a totally valid way to do that. But that's a lot slower and less convenient than if we just knew we had a list of things we could turn on where we could just quickly go click on them and say, I want entity bounding boxes on right now, right? So there's this concept of like collating that stuff into one place. And so there's a couple different ways we could do that. But at the very least, even if we decide we don't necessarily want debug UI for it, if we want to have it so that it still goes through the live code editing, then what I think we would want to do is at the very least make a file that's got all of those debug switches in there in some kind of like way that's easier to deal with, right? So that they can all be kind of seen and touched quickly. You know what I mean? So I feel like that's just kind of a, you know, kind of an obvious sort of adjunct thing that we want to do. So let's start working on that. Again, I don't have anything in particular in mind. I'm just going to go ahead and start doing some code transformations that I think will get us there, because, you know, I know roughly I need some buttons or something. I need some way of starting to interact with this thing. So let me just open up Handmade Debug. Again, as I should mention, it's day 190. So if you did a pre-order on handmadehero.org, you on day 190. So unpack that into a directory if you want to be lined up with us. All right, so in Handmade Debug, first thing I want to do, and I said I wanted to do this originally, is I want to get rid of these global variables here because we just kind of threw them in there when we were kind of working with it before. We already have the concept of debug state now. We really don't need these global variables for anything. So I feel like now would be probably a good time to sort of clear that out, right? To sort of stop dealing with any of those global variables, because we did the work already to have debug state that's stored. So I'm going to go ahead and get rid of those. And also, if I remember correctly, I feel like the fact that we were using those global variables also meant that our loop live code editing would break the debug system, right? I don't really remember if this is true, but I feel like it should have been true because the global variables would not get reset properly. I don't actually know if that's the case, but here I'm going to recompile. Yeah. So when I recompile, right, the debug system gets hosed, right? And so that's not a good thing. So again, that's another reason we want to do it, even if just not to just get the things out of the global scope so we just don't have these names floating around in the. Now, the problem that we will have, and you can actually already see it, is that we don't actually transform the mouse into that space at all. So we have the mouse position, we just use the mouse position directly to check for like hit testing and stuff like this. And that's not useful, right? That's not going to cut it. We need to like figure out where the mouse would be in the transform space. So that's another thing that we're going to have to watch out for. But at the moment, I'm not going to be too concerned about that. I'm just going to focus on sort of this other separate part. Okay, so transform-wise, we can pretty easily transform this guy by using the orthographic transform to change his shape as well. And we can also leave his shape the same in addition, like we can do something like this, leave his shape the same. But also control what his actual placement on the screen is, right? So I'm going to go ahead and do that one. We've got like the chart left, and we've got the chart bottom here somewhere, chart top, right? So if I want to have some way to move this around, I can just make it so that, like I said, I've got like a rectangle here or whatever that I've defined called profile rect. I could just make it so that the data actually comes from there. So, you know, somewhere I Is the translucent things you were talking about hard to do on 2D UI? Do you write the UI in the same Z buffer, or is it separate? So usually UI is easier to sort because, again, you kind of know exactly the order it should be drawn in already because it's already structured. So typically UI elements you just know, like, okay, here's the UI elements constructed with this goes on top of this goes on top of that. So typically you don't really need the Z buffer at all when you're doing UI. You would only use it, like I was saying, same thing for here, where you would use it for acceleration only. You wouldn't probably need it for sorting. Let's see. Don't see any other questions related to stuff we've done. So I think, wow, we may be done early this morning. Everyone can go get breakfast. SWTOR does it, talking about the 32-bit splits into two separate processes. SWTOR, Star Wars The Old Republic. Ah, okay. So it splits up into two separate processes. Gosh, that's really odd. I have never heard of that technique. I mean, when you say it, I'm like, okay, I see how you would do that. You know, you're trying to basically have more memory, so you're sort of implementing your own address windowing extensions at that point. Doesn't sound like a very good idea to me. I think you just want to stream more intelligently, but maybe, I don't know, maybe they had a good reason. It doesn't sound like a good idea to me, but you know, I don't know. I've never tried that. Let's see. Binding of Isaac does have scrolling between rooms, albeit a very quick transition. Is that really true? I didn't know that. Let's find out. So if I go to Northern Lion, pretty much sure I will get...
Hey channel visitors, I'm Northern Lion, and I wanted to
Here we go. Binding of Isaac. And of course we have to watch ads because it's YouTube. Heaven forfend. All right, well, we'll let that go ahead and catch up while I look at other questions. What is the drawing app we're using? We are trying Mischief. All right, so you're saying that he scrolls between rooms. I didn't know that. Wow, you're right. I never even noticed that. All right, so maybe I do want scrolling then. I wanted it to feel like that. So I guess a quick scroll is not a problem. It is crazy how fast that is. It's so fast I didn't even remember it was there. So yeah, I'd be okay with that because I never noticed it being annoying in Binding of Isaac. And so I think that as long as we kept it to that, I'd be fine with it. I'm totally fine with that. I just don't want the player to have time to think about what's in the next room before they actually have to deal with it, potentially. And maybe sometimes I do. I mean, I could believe that maybe once you go that route, maybe you get power-ups that allow you some time to look first. Let's see. So if I run things here, you can see that we kind of had a situation where we started making a little bit of a debug output, thing here. And some of these things, these debug output things, are like, stuff I can expand or collapse like this, right? And we haven't done anything particularly fancy, certainly, but that's, where we were at. And some of these things even were like different kinds. So like there was a 50 of value, and we wanted to make something where we could start interacting with that value. And where we left it, if I click on this, right, it just goes to an assertion here because we haven't implemented any way to interact with those. Because all we had was stuff where you could interact with by a click. Either it could like negate a Boolean, or it could, expand a tree view element of a group. But if it was any other kind of item that might have like, a value range to it, we didn't really have any way of interacting with that thing. And so if the reason for that, of course, right, is because we haven't talked about at all about how we might do user processing or any of that sort of stuff. So all we just had was just the click, and that's all we could do. So what I'd like to do, again, is like talk a little bit about the structure here and then start to implement some things so that we can have a more coherent concept of how we might deal with interaction in the debug system. And we won't go too far with it because, again, it's really not going to be something that's going to be in the game. So we don't, it's probably not even something that I might even spend any time on in reality here. But because this is an educational stream, I thought it was a good opportunity to talk about this a little bit. And I think it's something people should kind of have a reasonable understanding of, right? So here we are. Here's day 196. And this is sort of like UI input processing. All right. So you've seen me do some very rudimentary input processing. And it's the kind of input processing that a lot of people associated with the I am GUI style stuff, right? Which I am constantly asked about. And in general, what I mean by the type of thing people associate with it is they often associate I am GUI style processing with like single execution model, I guess I would say. Right? And what that means is if I have something like a checkbox and I've got a thing next to that checkbox, and what I'm going to do with this checkbox is I click on the checkbox and it checks it, and I click on it again and it like unchecks it or something like that, right? That's the interaction model I have. Then typically what ends up happening is in I am GUI, you will see something where they'll do like, you know, or they won't even do if checkbox. I guess if it's a checkbox, they'll just call checkbox, right? And then inside this checkbox routine, it will do something where it decides, you know, is the mouse in here and has it clicked? And if it has or not, it'll like toggle the check on or off, right? Then that's the most basic, the most straightforward way that you could possibly implement this thing. You know what I mean? Now, there's a problem with this way of thinking about things. And that is that it makes it rather difficult to decouple the way in which things work with, how should I say this? It makes it very difficult to decouple the interactions from the specific thing that is on the screen, right? So for example, if what I wanted to do instead was I had some kind of a selection paradigm. So I wanted to like select this thing. And maybe I had like a toolbox over here that was like my checkbox tool, and I had my selection arrow tool. And if I was on the arrow tool, when I clicked on this, it should select it. And when I had my checkbox tool, right, I wanted to like check it or whatever, you know? Then what that means is every possible tool that I might want to implement or every possible behavior that I might want to implement has to get stuffed inside this checkbox routine. Which means that the person who implements the checkbox routine has to be the person who knows everything that might ever actually occur here, right? Because the interaction cannot be written outside of the thing that it actually, outside of this actual call. Everything kind of has to happen inside there, right? And so I just wanted to point that out. That is sort of the thing that you've seen me do so far. And I don't consider that I am GUI at all. I just consider that to be one very simple way of implementing interaction processing that really has nothing to do with whether you're immediate mode or not. And specifically, the reason that I say that is because I am GUI, the immediate mode part of I am GUI, is only talking about the fact that these things are announced by the code, and it does not talk about the fact that the thing that is announced had to be checkbox, right? Instead, what could have been announced here was some generic thing that's just saying like, I have a Boolean, right? It has this information about it. And I'm not going to say anything about how I want you to process it as a UI element. I may just be putting these things into a batch, right, as part of the IAM pass-through that buffers up all the information about what ended up on the screen. And then it could have a totally separate set of code where people have implemented different tools, which will then scan through this batch and do things, right? Because there's nothing inherent about the immediate mode nature of the UI that requires you to not do this, right? The immediate mode nature is just about the fact that the calling code it doesn't have to save like a pointer. It doesn't have to call a create function to create some kind of a widget. It just announces the things that it has. And it just does them in a pass and it's done. Now, what it announces, on the other hand, is totally up to it. And again, that's one of the big reasons I say, like, most people don't seem to conceptualize IAMGUI the way that I had intended. Not that I really care, but that's just part of it. So what I'm going to kind of show here as we develop our debug UI a little bit more, I'm going to try to show you a little bit of how you might structure your code in such a way as to avoid this kind of a thing. Just because I'm assuming that everyone could find reference to how you do this, and I've already shown how to do it a little bit in the code. So for example, if we go into here to handmade debug, oops. So, you know, we've got a pretty obvious situation here. This is an example. We've got these debug profile things on the screen that we had been printing out. And if you press the left mouse button, it would just take whichever one you were over, right?